Hello friends, welcome to Learner's Planet. Friends, in this session I am going to discuss digital root concept in detail, right? So if you are appearing for any competitive exam, entrance exams in which you are to answer multiple choice questions, that means one option is correct out of the given options, then sometimes this technique is useful for you to save your time. That means you don't have to go for actual lengthy calculation. You can eliminate the answers or you can eliminate the wrong options and reach to correct option in seconds, right? So let's discuss this technique in detail. First of all, let's take up some examples and try to understand what this technique is, right? Suppose I have to do a multiplication, that is 123 into 123, right? And the answer to this problem is 15129, right? Now what I mean to say digital root is, if you add up this data, the digits of this number, that is 3 plus 2, 5 and 1, 6, right? Put multiplication sign over here, 3, 4, 5 and 6. Now 6 into 6, 36, then 3 plus 6, 9. So this 9 is actually digital root of this product, right? That means sum of the digits, and this digital root is 9 over here. It should be 9 over there also, right? Just take it up. 5, 6, 7, 8 and 9, 9 plus 9, 18. That means 1 plus 8, that is 9. So in examination, you can eliminate the option by this technique. Suppose your digital root is coming to be 9, and in the options if there is only one choice that is giving you the sum as 9, then that will only be the correct choice, right? You don't have to go for actual lengthy calculations, right? Now you have to be careful that if we have product sign over here, then these numbers will be multiplied. If we have addition sign over here, so the first step will be added, right? Now how? So it is 123 plus 123 and the answer is 246, right? So it is 6 plus 6, that is 12, right? So 1 plus 2, the digital root is 3 over here. Now what is over here? 6 plus 4, 10 and 2, 12, that is 1 plus 2, that is 3. Okay, so if it is multiplication sign, you multiply them. If there is an addition sign, you add them, right? Now let's take up one example. Here you have to multiply 2347 and 1752, and the correct answer is among these among these options, right? Now you don't have to go for actual multiplication, just try digital root method and unit digit method, right? First of all, 7 2s are 14. Unit digit is what? Of this multiplication will be definitely unit digit will be 4, right? Since 7 into 2, 14. Right? So the first option is eliminated, right? Second thing, I'm just discussing 2-3 methods over here. It is 1752, that is around 1750, and this data is 2347, that is less than quite less than 3000. So the multiplication 1700 into 3000 will not give you the figure more than the unit figure, that is the first figure more than 4, right? So this option is also eliminated. That is, we won't be able to get a data with 51 lakh, right? Because to get 51 lakh, there should be 3000. Okay, bit less than 3000 because we are having 1752 over here. So even this option is eliminated, right? So this is approximation technique. We eliminated this option by approximation technique. We eliminated this option by unit digit method. Now let's see from these two which one is the correct answer, right? Now we just find out the digital root of this product. Now what will be the digital root? It is 3 and 2, 5 plus 4, 9. If you are getting 9, eliminate that. The next number you take as it is. So the digital root of this will be 7. If you take 9, then also it's okay. If you do not take 9, then also it's okay, because if you add 7 to 9, you'll be getting 16. Further, the digital root will be 7 only. So in any digital root, if you do not add 9, then also it doesn't create any difference, right? So the digital root of this is 7 into, here 7 plus 2 9, eliminate that, 5 plus 1 is 6. So 7 6 are 42. So the digital root is 4 plus 2, that is 6. Now our correct answer will be the number whose digital sum will be 6. So just add it over here, is 4 5 6 7 8, 8 and 8 16, 16 means 7, that is 1 plus 6, that 7 and 2 is 9. So 9 plus 4 13, so you are getting 4 digital sum over here. So this is not the correct choice. Now we are left with this choice only. So obviously this will be the correct answer. Still you just cross verify. It's 4 5 6 7. We are not taking 9. So 7 plus 4 11, 11 plus 4 15, that is 1 plus 5, that is 6. So the digital sum of this is 6. So this will be the correct choice, and even you can match the unit digit also, that is 7 into 2 14. Unit digit over here is 4, and there is none of these over here, so you don't have to worry that the answer will be incorrect. It will be definitely correct because other 3 are wrong options. Okay, so this is in this question we discuss 3 techniques: approximation, unit digit, and digital root. Right, now we take 1 or 2 more examples. Now let's see this problem. 7835 into P gives 995045. Then we have to find out the value of P, right? Now do not try to get the value of P like this: 995045 divided by 7835, and you are finding out the digital root of numerator and then digital root of denominator, and you are getting the value of P. You cannot do this, right? It will not give you the correct answer, right? Now what will be the correct way of doing this problem? Choose P among the options, then find out the digital root of left hand side and then match it with the right hand side, right? Now what is the digital sum of right hand side? That is 9 is cancelled, 9 is cancelled, this further 9 is cancelled. The digital sum is 5 of right hand side. Now we have to see a number from the options that gives the digital sum as 5 after multiplying with this, right? So first of all, this we just try to find out the digital sum of this. So it's 7 plus 8 15 and 5 20, that is 2. 2 plus 3 5, right? So from options we have to choose a number whose digital sum is 1 only. So that is 1 into 5 will give us 5, right? So let's take up option 1. It is 135. It's eliminated because the digital sum of this is 9. So 9 into 5 will be 45. So the digital sum of left hand side will be 9 only, right? This 5 is this, and this P if 135. So the digital sum will be 9. So the digital sum of left hand side will be 4 plus 5, that is 9, and on the right hand side it is 5. So it's eliminated. Moreover, if P is 135, then if this is also multiple of 5, this is also multiple of 5, so their product will be actually multiple of 25. So the second last digit should be either 2 like this 25. This 2 digits should be either 25, 50 or 75, right? So it's not there, so even it is not the correct choice in any case, right? Second thing is this 2 3 4. So here this 5 and this into 4, so it's 20. So the digital sum is 2 plus 0, that is 2. So even this is not the correct choice, right? Now over here 7 plus 5 12 and 1 13. So it's 5 into 13, that is 65. That is 6 plus 5 11, that is 2. So the digital sum is 2. So even this is not the correct choice. So what is the correct choice left with us is 127. 7, 8, 9. Then we are left with 1 only. So 5 into 1 is 5, right? So 127 is the correct choice. Okay. So this is what the digital sum method. Now let's try to do this calculation by various techniques. It's not just digital root technique that can be used. You can use approximation technique, digital root technique, as well as unit digit concept, right? So let's try this. Now 5358 into 278. The unit digit over here is 8 and here it is 8. So 8 8 jar 64. That means the unit digit of this product must be 4. So this option is eliminated. All the three other options are having 4 at the units place. So now we have to choose the correct among them. The second thing is this number is multiple of 2, right? Since it is an even number, this number is also multiple of 2. That is since it is also an even number. So that means the product should be multiple of 4 definitely, right? So your answer should be multiple of 4, right? Now what is happening? What is the divisibility test of 4? The last two digits should be divisible by 4. Okay, so in this case the last two digits are divisible by 4. In this case yes, but in this case no. So this won't be the correct choice, right? Now the third thing is, it is something around 6,000. Suppose I take it as 6,000 and while approximating to higher side, and even if I approximate this to or higher side, that I'll be getting 300. So 6,000 into 300, the first place should be still 1, right? That is this place. This place should be 1. Okay, so we cannot get this answer at any cost even after approximating both the numbers to higher side. That means it's quite low from this. So even this won't be the correct choice, right? So we are left with this. This only will be the correct choice. Still we just find out the digital root, right? And if we get the same digital root, then definitely it is a correct choice, though we do not have none of these with us, right? So it's 5 plus 3 8, 8 plus 5 13, 13 plus 8 is 21. So the digital root is 3 into 8 plus 7 15, 16 17, that is the digital root is 8. So 3 8s are 24. So digital root is 6, right? Now just see, in this case let's first of all eliminate 9s. So 5 plus 4 9 is gone, this 9 is gone, 8 plus 1 this 9 is gone. So it's 4 plus 2 6. So digital root is also matching. So this is the correct choice. Uh, Friends, to find out this answer, if we just had adopted the digital root technique, what would happen? Let's see, right? So we had already eliminated this and this. Now see this. The digital root of this calculation is 6. Here we got 6 only. Now just see over here. It's further, let's eliminate 9s. So 9 is gone. 8 plus 1 9 is gone. 4 plus 4 8, 8 and 3 11, 11 plus 4 15. So the digital root is 6 even in this case. Now you got the digital root as 6 in this case and in this case also. Now how would you choose the correct option? Okay, so that becomes a problem if you just go by digital root method only. Okay, so digital root method will be applicable if you are having the digital root of all the options as unique or different, right? Otherwise you cannot eliminate the options. Now you have to choose between these two, right? Now the second method, which I told you, that this number is multiple of 2, this number is also multiple of 2. So the product must be multiple of 4 definitely. So 34 is not multiple of 4. So you can eliminate it, though the digital root is 6. Okay. So the digital root 6 is not for only this number. There are thousands and thousands of number giving the digital root as 6. But every number cannot be the product of these two numbers, right? So digital root technique is applicable when the digital root of all the options are unique, right? So if you are having the two options with the same digital root, you have to apply another technique to eliminate the incorrect option. So what we did over here, we just observed that the numbers are, if both the numbers are multiple of 2, that means their product should be multiple of 4, and this option B is not multiple of 4. While just looking at the last two digits, that is 34 is not multiple of 4. Okay, so we got the right answer as option A. Now let's take up this multiplication. 78.2 into 514 into 3.36, and which of the following is the correct choice, right? Now, as I have told you that decimal plays no role in digital root technique, right? You just have to find out the correct position of the decimals. Otherwise, you just go as you are going, right? Now, what is the digital root of this? 7 plus 8, 15, and 2, 17. That is 8 into this 9 we eliminate, that is 1 is left. Then 9 is eliminated, only 3 is there. So 8 into 3, 24. So the digital sum is 6. Now we have to choose then which of the following options have digital sum as 6. Apart from that, you can eliminate the option if you don't want to find out the digital sum of each and every option. To save your time, you can eliminate options apart from digital technique also. See, all the three numbers are even numbers, right? So this is multiple of 2, this is multiple of 2, this is multiple of 2. That means your final answer should be definitely multiple of 8, right? So which of the following options is not multiple of 8? You can instantly eliminate that, right? Say, for example, we choose 528. What is the divisibility rule of 8? That is, the last 3 digits should be divisible by 8. Right? So 528, let us see whether it is divisible by 8 or not. 8, 6 are 48, 4 and 8. So it is divisible by 8. It is also divisible by 8. If it is, then it cannot be because it is 28, it is 18. So it won't be divisible by 8, and even it won't be divisible by 8 since 8, 6 are 48. 6, 8, it's not divisible by 8. So we don't have to find out the digital sum of these two numbers. Now we just have to find out the digital sum of these two numbers only. Now let's see in which case do we get 6, right? So let's see this option. 3, 4, 4 and 5, 9 cancelled. 5 and 4, 9 further cancel. 5 and 2, 7 plus 8, 15. The digital sum is 6. So definitely it would be the correct choice because there's only difference between these two numbers. Instead of 3, it's 4 over here. So the digital sum will be, in this case, will be 7. So it won't be 6 since there is a single difference. Okay, so you don't have to add up the digits. So definitely this will be the correct choice, right? So you saw, instantly we get the correct answer without going for actual multiplication by applying 2-3 techniques. That is unit digit concept, that is divisibility rule, that is digital root concept, right? So friends, I'm sure if you practice well, then gradually you'll be able to apply all these techniques, right? So start following the techniques or start applying the techniques immediately on the problems. You will definitely be getting good opportunities to apply all these techniques into your data interpretation problems. Okay, let's do 1 or 2 more problems. Now friends, here we have to do a calculation, and in options, suppose we know only the last 2 digits, right? And in the question it is asked that we have to find out the last 2 digits, right? Now this cannot be a complete question. It will be a part of question maybe of your data interpretation problems, right? In which you have to arrive at the correct answer by multiplying these 3 big numbers, right? Now how do we approach this problem, right? Digital root concept may be useful over here, may not be. Okay, so we just have to be clear with other techniques also. Now, since we have one different unit digit over here, first of all, let's try to find out whether this is the unit digit or anything else. So it's 9 2s are 18, 8, drop 1, take 8, that 8 into this 3, 24. So the unit digit is 4, right? So this won't be the correct choice, correct answer for this multiplication, right? Apart from that, This number is multiple of 4 in fact. So your answer should be definitely multiple of 4. So even it won't be the correct choice, because what is the divisibility rule of 4? That is, the last 2 digits should be divisible by 4, right? So even this is not multiple of 4, so it won't be the correct choice. Now both of these options are having unit digit as 4 and both of them are multiple of 4 as well. So we have to approach for one more technique to find out the correct answer, right? That means we have to now find out the second last digit, or we can say tens digit, right? So how do we find the tens digit? Just listen to me very carefully. See, if you wish to find out the last 2 digit of any multiplication, you carry on with the last 2 digits only. You can drop the 100th digit, or you can drop the this third digit from the left, from the right, I'm sorry. So here you can drop 5, here you can drop 3, here you can drop 1, right? Apart from that, I just write it over here. It's 89 into 12 into 3. From this multiplication also you can get the second last digit. Apart from that, if you wish to find out last 2 digits, just listen to me carefully. If we divide the calculation, that is over here whatever we are having, calculation by 100, we will get last 2 digits, right? So if we divide 89 into 12 into 3 by 100, we will be getting the last 2 digits. Now you can multiply them and divide by 100, then it's no point to uh, go for any shortcut technique. So what you do is you divide individual number by 100 and get the last 2 digits. So if 89 is divided by 100, the remainder will be 89 only. So the last 2 digits will be 89. So instead of 89, what we can do is 100 minus 89, that is 11, right? But 89 is there, so it is minus 11 from 100. So what I can do is, it's minus 11 into 12 into 3. Okay, don't worry, I'll repeat the problem once again. Just listen to me carefully, right? It's minus 11 into 12 into 3. We are having a minus sign over here, right? So first of all, I just drop this minus sign, put it aside. 11 into 12 is 132. I'll be continuing with 32. I'll be dropping 1, because 132, if I divide it by 100, the remainder will be 32. So the last 2 digits of this product will be 32 only. Then it is 3. Now 32 into 3 is 96, and we are having a minus sign over here, right? So the last 2 digits will be minus 96, or we can say 96 bar. So the last 2 digits cannot be negative, so we deduct it from 100 to get the correct last 2 digits, that is 04. So this will be the correct choice. I just repeat it once again. See, if you wish to find out the last 2 digit of any multiplication, then you can divide that product by 100 and just get the remainder. So whatever the remainder you are getting, that will be the last 2 digit of that particular product. It's very simple concept, no algebra, big algebra over here. Suppose you wish to get the last 2 digits of maybe 123. So if you divide 123 by 100, whatever the remainder you are getting will be the last 2 digits, isn't it? So 23 is the remainder. So these are the last 2 digits of 123. Okay, so the same funda we are applying over here. Now 589, 312 and 103, right? All of them are 3-digit numbers. So if we divide each of them by 100 and get the remainder, so in this case the remainder will be 89. In this case, the remainder will be 12, and in this case, the remainder will be 3. Still, 89 is a big number to multiply. So what we do is we try to find out the negative from 100. So 89 is minus 11 from 100. So remainder in this case and remainder in this case will be same except the negative sign, right? So how do we solve that negative sign? I have already explained. Once again, I'll explain. First, listen to me carefully. 89 is minus 11. Then this is 12 and then this is 3, right? Now 11, I just put negative sign apart. 11 into 12 is 132 and this 3, right? So it is 132 If I divide it by 100, the remainder will be 32. 3 will be 3 only. So it's 96. That is minus 96. So if I divide this expression by 100, I'll be getting the remainder as minus 96. But the remainder cannot be negative. So what will be the remainder? That is 100 minus 96, or I can say 04. So the last two digits of this product will be 04, and the last two digits of this product will also be 04. So that's why this is the correct option. Okay. See, I'm explaining you too much, but you'll be getting confidence only after you take up some problems on your own, use your calculator, try to make some of the problems, then apply all these techniques. Then you'll be getting confidence. Listening to me again and again will not help much, right? Friends, I have discussed a good number of techniques in this session for last 15 to 20 minutes. But I'm sure you will be getting confidence on applying these techniques only after certain practice. So try to make some problems on your own. You can make the problems on your calculator itself. Just make up some problems. Choose the options according to your choice, or you can take up some problems from any of the books. Then try to apply all these techniques. Okay, after doing 15-20 sums, you'll be getting the confidence on the various techniques which I have discussed in this session. Okay, just listening to this session again and again will help not much, right? So I hope you might have enjoyed the session. So we'll be discussing more such techniques in our coming sessions. Do revise, and all the best.